Okay, a very good morning to all of you. I'm sharing the QR code. So give the QR code, then we will start. Okay, so I think QR code scan is done. So we can start. Okay, so first of all, I will share the presentation with you and then we will start. Okay, so my previous class, if you check it out, then I was discussing with you about Kelvin double bridge. Okay, for Kelvin Kelvin double bridge for low resistance calculation. Okay, and I told you that this Kelvin double bridge is helpful in calculating this range. You can see here it's 1 to 0.00001 ohm. Okay, so with high accuracy. So Kelvin can measure this amount of resistance with high accuracy, very high accuracy. Okay. It's a very helpful thing. And so I also told you that was the principle of Kelvin bridge and derivation of finding unknown resistance value, that I also told you. Now, the thing was that we were facing difficulty in finding out the resistance value without using Kelvin. So we, after using Kelvin, we can get accurate low resistance value. So that we will check out once. So let you see. So let us follow that particular diagram. Wait. So let me share my whiteboard to you all. I think my whiteboard is visible. So we need to construct a Kelvin bridge just similar to that of the you can say Wheatstone bridge, but the only difference will be that it will be consist of two arms P and Q, small P and Q. So let me show you that thing first, how you will draw. Very simple. So if you have your pen and copy, please draw with me. A very rough structure I'm drawing. Okay, not something because without this diagram I won't be able to make you understand. And in yesterday's lecture, I mean in previous lecture, I have already, this is the battery. E is the battery here. Okay, the supply. And so from here we will draw. Wait. Very normal diagram I'm drawing just to make you understand. So you just check out any book if you have. Okay, so it's not so proper, but still I'm trying. So this is the B point, okay? And here a galvanometer is connected here at this position. This is the galvanometer G. So I'm not able to draw here. It is the capital Q resistance. It is the small q, okay? And here again, this is the capital P resistance and this is the small p, okay? Then this terminal is A, and I told you A, B, C, and this terminal will be C. Okay, so I'm changing the pen color. Okay, and so it will be a bit stretched diagram, and this is the R, and Mn, and this point is M, and this point is N. So Mn, and this point is D. Okay, so A, B, C, D point it's cover, and this is PQR, and this is Mn. These two terminals I have taken. So through this current I will be flowing. Okay, current I will be flowing, and this is another one variable resistance, but which you can name it as RP. Okay, so here this construction is more or less equal to Wheatstone bridge. Only the difference is that it will be having extra 2 ohms. That is, you can see this P and Q and small p and small q. Okay, so where the P and Q is connected at one end, so here you can see terminal is D, and PQ is connected to another end where terminal is B. So this terminal, the namings are important. This is one, the B portion. Okay, so this connection actually minimizes the effect of connecting leads. Okay, leads is a very important thing. This was there also in Wheatstone bridge. So connecting leads, and unknown resistance R and the standard resistor S, okay, is placed between, we have to place that between M and N. So let us place that. So here I will place the resistance R, capital R, you see here I have placed here, and here for this resistance I will place capital S. Okay, so I will have placed the R and S in between M and N and A and C respectively. So you can see it very clearly. So from the derivation, one thing is very clear, that from the derivation what we will do, that the ratio small p upon small q, that will be from the picture. From the picture is clear, small p by small q, that will be equal to capital B by capital Q. So under the balance condition, current in galvanometer is always 0. Okay. So in balance condition, if you want to say, balanced means galvanometer is, the current through galvanometer is always 0. The current, the I. Okay, so I is always 0 in the galvanometer. So that I want to tell you in balance condition. Now the potential difference at A and B, that will be equal to the voltage drop. So where is A and B? This is A, this is B. So you need to also check the voltage drop. Voltage drop, that will be between somehow somehow in this area, somehow this region, that is A, M, D, here terminals are given. So now we will have to write for the terminals EAB. So we will denote the name as EAB. So let me tell you that. So EAB, check it out, the terminal EAB. EAB will be equal to P, capital P divided by capital P divided by P plus Q. Okay, capital P divided by P plus Q, in bracket you put, and then you put outside EAC. Okay, so EAB will be following this formula, P upon P plus Q EAC. Now what is EAC? What is EAC? EAC will be another some terms. So EAC, what is EAC? EAC will be some term with R and S. So let us check into that. It will be I. I is the current flowing through it. Okay, and then R plus S. Okay, R plus S plus, in bracket you will take, you have to again take a bracket, and you have to P plus Q, small p plus Q. Okay, then divided by R. Divided by R. Then you close the bracket, make a divide sign, and then you have to do the summation of all the resistance, P plus Q plus small r. Okay, Q plus small r, and then you just close the bracket. So this is the thing. Okay, again for EMG, this is for EAC. Another you have to take for EMD. That is one. This one AMD. Okay, EAMD. So what will be EAMD? It will be just similar to this I, but a long derivation equation you have to put. So it will be I. So if you have copy now, please write it down, whatever I'm writing. R plus, here you have to take the P, the small resistance divided by P plus Q. Okay, divided by P plus Q. Then you have to close the bracket and then put a multiplication sign. And we have to multiply it with the rest of the terms. That is P plus Q, P plus Q. And then outside you have to put a R because it is the small r. And then you have to take again P plus Q plus R. Okay, so this thing will continue as per. So you have to just close the brackets. So this for EMD. So this is if we take, so in my previous class, I told you two equations, if you remember. One is, let me write it here also, otherwise we will forget. One is, if you check my, one is R1 by R2 is equals to P by Q. Okay, this was my one equation from my previous lecture. And second, another equation that we derived was R equals to P by QS, P by QS. So these two equations are equation 1 and 2. And now today what I am doing, that is equation, this is for EAC, you can take equation 3. Okay, and this for EMD, whatever. And now I will write again the derivation for EAC because I now need to replace the EAC. So how I will do? So let us do that. So now EAC can be written as I. Okay, I. So in bracket you can put not I dash, sorry, wait. I, it will be PR. Okay, it will be PR divided by P plus Q plus R. Something like this. Okay, so this we can put as equation 4. So from my previous class, these are the two equations, equation 1 and 2, equation 3, equation 4. And now, suppose if the galvanometer is 0, then what we will do? Then the equation will become, when the galvanometer is 0, G is equal to 0, then what will be the equation will come? So then P divided by P plus Q, these are all capital P, don't remember, okay. This will be multiplied by I, then in third bracket you will write R, third bracket R plus P divided by P by Q, P plus Q, okay, small p, this will be with small p. And in bracket you have to close, you have to again put a bracket and you have to write P plus Q multiplied by R divided by P plus Q plus R. Okay, then you have to just close the bracket, close all the bracket. This will be equal to I PR divided by this small r, okay, P plus Q plus R, P plus Q plus R. So this is the total equation we can do from the if the galvanometer is 0. Okay, so last equation what we can write for R as I told you, the unknown resistance. For that we can write P divided by R, okay, multiplied by S plus P plus PR, small p, small r, divided by P plus Q plus R, okay? P plus Q plus R. Then you will then you will take a bracket for the capital P divided by Q. So capital P divided by Q, and then we have to also subtract it from small p by small q. So whenever we are writing small terms, remember, we have to write also small p. So again, we know from my previous equation that since I'm putting the sign of since p by q is equal to small p by small q. So you can put this value here. So R we can write in short form. That is definitely p by q, okay, multiplied by s. So this is my equation number 5. Okay, so the motto of this equation is that for obtaining perfect results, the arms ratio should be maintained equal, and the thermoelectric electromagnetic field that are induced here, okay, that sometimes need to be checked for taking the readings. That is important, because when you are using Kelvin double bridge, you have to check out the readings also. So by changing the polarity of the connection, so that we have to also do. So therefore, wait. So therefore, the unknown resistance value can be obtained from both the two arms. Okay. So typically, I told you it measures 1 to 0.00001 ohm with an accuracy of near about. You can say it gives an accuracy of plus minus. Okay, I'm writing here. I'm writing the down. It gives an accuracy of plus minus. So I use this 0.05%. 0.05%. 2, you can take plus minus 0.2%. So this is the accuracy of Kelvin double bridge. Very, very important, because in short question type, you can get this kind of questions, that what is the accuracy level of Kelvin double bridge. So in order to achieve sensitivity, the current that need to be supplied, it should be large. Okay, so more sensitive, you need to also give the proper current to the to this Kelvin double bridge. Okay, so one more thing I want to discuss. Let me tell you. Okay, so Kelvin double bridge, these things, I hope this is more or less clear. Our main intention was to show you that how we can equate a capital P upon Q equals to small p upon small q. Okay, so this is the main thing. And another is R equals to this one, P upon Q multiplied by RS. So if this equation comes, then we can again write now P by Q will be equal to R by S. So this line we can also write from the above equation. So these are the derivations we can obtain from the above equation. So now we can wait. We can do a problem. We can do a problem. So before that, I want to tell you some of the points. Remember, advantages of Kelvin double bridge is that it can measure the resistance, okay, value in the range of near about advantages. First of all, it can measure the resistance at a range of 0.1 microampere, okay, to 1 ampere. Clear. Second is that the power consumption is much more less. It's a very important thing. Simple in construction and sensitivity is very high. For disadvantage, you can take that the bridge is balanced or not, but the galvanometer as we are using, it is very, it has to be very much sensitive. Okay. And to obtain good sensitivity of the device, a high current is required. I told you that we need to give a large current. So high current is required. That is the, it comes under disadvantage. Okay. Disadvantage I'm writing here. Okay. Next you can take manual adjustments. Sometimes are required periodically. Okay. Sometimes if any readings are not coming proper, then we may go for the manual adjustment. So application, if you come for Kelvin double bridge, it is used in unknown resistance to measure for wear. Okay, so now can you tell me why is Kelvin double bridge used? Why? I told you now that Kelvin double bridge is a modified form of a Wheatstone bridge, okay, to measure the load resistance. Okay, now you tell me the question, why Kelvin double bridge used to measure load resistance? Do you have any idea? Do you have any idea about this? Tell me why. The question is, listen to me. Why is Kelvin double bridge used to measure load resistance? We all know that Kelvin is used to measure load resistance. Why we use Kelvin? Can you tell me? Anyone? Ayushi, Asad? Today many are present. Ayushi, Asad, Rani, Rupam. Any answer? Any idea you have? Then share with me. Yes. Am I audible, na? Hello?
Yes, ma'am.
Tell me the answer. Why is Kelvin double bridge used to measure load resistance? See, I taught you some errors also, significant errors, all those errors. So actually what happened in measuring load resistance in case of Kelvin double bridge, some significant errors come in the reading. Okay. So no, not Kelvin, actually in measuring low resistance actually in any with any device, with any other device, some significant error in reading actually occurs. So hence to overcome that thing, that error, we use Kelvin double bridge. So this is one of the advantage of Kelvin double bridge. Okay. Now you tell me one question. When the bridge is balanced, how much current flow through galvanometer? Can anyone tell me? When the bridge is balanced, I'm telling, when the bridge is balanced, how much current flows through galvanometer? Yes, Pooja? Yes, Pooja? Tell me the answer. When the bridge...
Zero.
Zero. Yes, zero. Correct. Correct, Pooja, correct. Okay. My next question is, what is the effect of load and contact resistance in Kelvin bridge? You have seen now that we have previously also in Wheatstone bridge, we have talked about load and contact resistance. So can you tell me what is the effect of load and contact resistance in case of Kelvin bridge? You have an idea? Anyone? Josna? Josna, are you there?
Yes, ma'am.
Yes. Do you have any idea? What is the effect of load and contact resistance in Kelvin bridge? See, Kelvin double bridge is independent of load and contact resistance. Okay, so you need not to think about it that what is the effect of load and contact resistance. Okay, just now I discussed with you the accuracy of Kelvin double bridge, that is plus minus 0.05% to plus minus 0.02%. Very important. Okay, plus minus 0.5% to plus minus 0.2%. So this is the variations of accuracy. Very, very important. Okay, this point. Next is these are some of the questions. So one problem we can do. Take down the problem, please. Write down a Kelvin double bridge. A Kelvin double bridge balanced a Kelvin double bridge balanced having the ratio arms 100 ohm. I mean sorry, I missed ratio arm, this outer one. Okay, so you can write outer in bracket. So Kelvin double bridge balance has the ratio arms in bracket. You write outer means bahar ka jo resistance hai, that one, that is 100 ohm, and the 100 ohm inner yeah, outer arms both are one is 100, one is 1000. That means I am writing here in short form, that is outer arms mean one is P, one is Q. So P is, you can take 100 ohm, P is you can take 100 ohm and capital Q you take 1000 ohm. So these are the two outer arms. Okay. And two inner arms which we have, that is small p. Small p you take down 99.9 ohm. 99.9 ohm, and small q you take down, the value is 1000.6 ohm. These are the values. So I gave you the arms values. Okay. So when you take down resistance on the link is 0.1 ohm. That is, you can take the R. Okay, R is 0.1 ohm. Resistance on the link is 0.1 ohm. Wait. And standard resistance S is 0. So S I'm writing here somehow. S I'm writing here, that is 0. 0.00377 ohm. Take this value. 377 ohm. This is the value of S, standard resistance. Okay. And small r you take down, which I told you, resistance of the link, that is 0.1 ohm. 0.1 ohm. Okay. So this is all the things, and you have to calculate the value of unknown resistance. So all these data are provided in your problem. Okay. So you have to calculate the unknown resistance. So I'm just moving back to my equations where what I have done. So let me check it out, those things once. So let me tell you which equation you will use. Okay. So you have to use this R equation because you need to find out the unknown resistance. Okay. So I'm writing the equation in my next page here. Wait. So all the values you have taken down, all these values, outer ratio P and Q, inner ratio arms P and Q, value of standard resistance and value of small r. You have taken down, everyone? Please respond. If you don't respond, it's very difficult for me to understand. Hello?
Yes, ma'am.
और मैं सिर्फ एक जने को नहीं बोल रही हूँ, मैं सबको बोल रही हूँ present in this class. If I ask you, you have to respond. Otherwise, I will not give you any attendance. And I'm not talking this to only Ayushi or only Pooja or only anyone. I'm talking to everyone. Sushila, Shreya, Shikha, everyone. Okay, so I'm moving to the next page. I'm writing the formula here again for your sake. So R equals to P by Q multiplied by S. You will put the values, okay, and you will tell me the answer. And here you will take QR divided by Q plus R, okay. This is the modified formula, into which you have to put the values. Okay, so remember this formula nicely for problem purpose. So P by Q minus small p by small q. Okay, so this is the equation. So you have to put the values. So I hope you know all the values. You know P 100, Q is 1000, S you know. S is what? S is, so I'm writing the values one by one. You also write with me and you will tell me the answer also. Because right now I don't have calculator. So kindly calculate and tell me the answer. So this will be 377, okay. Plus we have QR. So what is QR? Q will be the 1000.6. Okay, 1000.6 multiplied by R. R is I think 0.1, which I told you. R is 0.1 and P plus Q plus R. So small p is 99.9. 99 point, how much I told? 99.9. So you can take 99.9, okay, plus 1000.6 plus 1000.6 plus 0.1. So this is my this one, and here you what you will put the values and you will tell me P by Q and what. Tell me the value. You have the calculator with you. Put the values and tell me the answer. Here you again put P is 100, divided by Q is 1000.6 and minus small p is 99.9. Sorry, and this will be Q is how much? Q is 1000. Q is no. Sorry, capital Q is not 1000.6. Capital C. I'm doing wrong thing. Even nobody is telling me. How nice. And this small q is 1000.6. Do the calculation and tell me the answer fast. Tell me the value of R. Tell me the value of R, please. Fast. क्या है पूजा? Calculation किया? Hello. Hello. हेलो
No, ma'am.
क्यों नहीं किया? मैं करूंगी क्या कैलकुलेशन पार्ट? आयुषी
हम कर रहे हैं.
हाँ करो, जल्दी करो और मुझे वैल्यू बताओ, आर का वैल्यू बताओ. सभी तो कर दिया, सिर्फ आर का वैल्यू तो पुट करना है, इसमें भी इतना प्रॉब्लम. Everything we are doing for you, but you people are nothing doing for us. This is the main problem. ऐसे प्रॉब्लम्स आएंगे एग्जाम में, मैं बता दे रही हूँ पहले से. नहीं आता है तो नहीं आता है, देखो तुम. थियरी क्वेश्चंस बहुत ही कम देंगे, सारे ऐसे न्यूमेरिकल देंगे. आज तक I have done many numericals with you people. Even in the first chapter also, those standard deviation, error, all those. I'll give those numericals. See, all numerical will be there in your questions. Tell me the answer. If I wait for you answer na, see the answer will be somehow 0.389 milliohm. See, somewhat like this. If you get this kind of answer, then your answer is correct. Okay, this is my answer. If I sit for your answer, then I won't get it. So this kind of question will come. So make yourself prepared. Okay, this is the type which though it will be if you have objective type of test, then also this kind of question will come. So make sure that you, yes, bolo Ayushi. Pooja.
I got 0.377 million.
3.3. Okay, near about approximate.
Ma'am, because I take the P by Q and PQ as that is equals to, that's why I take similar.
Oh, okay. Yes. Okay, fine. It may be somehow approximately, but ठीक है. वो वैल्यू भी करेक्ट है. क्या है? 0.377. ऐसा कुछ है क्या पूजा?
Yes, ma'am.
Okay. ठीक है, अगर किसी का ये वैल्यू भी आ रहा है, then it is also correct. Okay, so both the values are more or less correct. So this kind of problem you will get in your exam. So make yourself prepared. Only 13 students come in the class. Rest students, I don't know what they do. Okay. So tell them also, be prepared for their exam purpose, all these questions and all. So Kelvin thing, I have told you everything here in this Kelvin. So I'm done with my Kelvin part. From my next class, I will move on to next pages. Okay. So up to this, if you have any query, please tell me. And one more thing, make sure you understand the disadvantage of Kelvin double bridge. That is also very important. Okay. यो याद रखना है, applications भी याद रखना है. अच्छा. And so we were till now we were discussing with ये कौन से type of bridges है? Wheatstone or Kelvin? Can you tell me AC or DC bridge? AC bridge or DC bridge? What?
Ma'am, DC.
Yes, very good. DC bridge. So don't mix it up. We have not yet started AC bridges. We are just still stuck in DC bridges. So DC bridges we have covered Wheatstone bridge as well as Kelvin double bridge. Okay. And some questions I asked you today. So those questions are also important. That why Kelvin is used for measuring load resistance, the difference between Wheatstone and Kelvin, then accuracy of Kelvin, then what is the effect of load and contact resistance in Kelvin. Okay, these are some of the important questions. And DC bridges, what are the two types of DC bridges we use? So another bridge is also there in DC bridge, that is called Megaholm bridge. So I think that is not in your syllabus, so we will not go into that. So main advantage of Kelvin double bridge is that it can measure even very small resistance value. Okay, this is one of the good main advantage of Kelvin. So I told you low resistance, accuracy I told you. So it can also measure a very small resistance value. So in many places, in place of Wheatstone, we opt for Kelvin, where we need very accurate result. And so this is all about the Kelvin double bridge. And okay, so let me once again share the QR code with you. I think those who have not came late a bit with share. Wait a second. If anybody has left out, kindly give your QR code password, because after this class you won't be able to give your attendance. Okay, so give this. This is will be only calculated. Okay. Start your studying from the beginning part. What I have taught you, all those things. And so I'm done with Kelvin. So from my next class, I will start with AC bridges. And do you have any question from Kelvin double bridge? Then feel free to ask me. Go study, listen to my videos again. I am already uploading the video section every day. Okay. So whatever I'm doing, take it down in your copy, make a note, proper note, and study. Then also, if you don't understand, then you tell me. Okay. And this kind of problems to practice. Thank you so much for attending my class. If you have given your QR code, then you can leave.
Thank you, ma'am.
Thank you. Thank you so much.